All right, our transition math review. This particular a set of problems, these first five, actually are just a different infusion rate formula, where if you already know the infusion rate or the pump, what you're going to set the pump at, and you have the drip factor, it can actually calculate the infusion rate for us. They actually have a formula down below, and I went ahead and rewrote it this way because that's really all it is. If you know, the hourly infusion rate is milliliters per hour, and of course the bottom number is our standard drop factor. So let's go ahead and do these really quick. It says the prescription is to infuse continuously at a rate of 150 milliliters per hour with a standard drop factor of 4. So if you take the 150 milliliters per hour and you divide by the standard drop factor of 4, all you have to do is divide that to put it in the calculator. It's 150 divided by 4. That's going to give us 37.5 drops per minute. It's just a different form of our infusion rate formula. Second semester, I think that they want you to be exposed to this, but I think only transition is responsible for knowing how to do this one. Okay, so the other infusion rate formula that you saw on the other review, everyone is responsible for. Now on number 2, again, just continuing it, if we're going to infuse at 60 milliliters per hour, and then you divide by the standard drop factor, this gives us our infusion rate. And on this one, that is 10 drops per minute. Also, don't forget, drops can be abbreviated that way, this way, or the word drops. All three of those are accepted. Let's do number 3. This time we're infusing at 80 milliliters per hour. And the drop factor is 3. We're going to put it into the calculator. Now, because we are looking for drops per minute, I'm going to go ahead and have you round the answers to whole numbers. It doesn't make sense that you're going to do drops out to the tenths or hundredths or whatever. So even though we got 26.666 when we put in the calculator repeated forever, we're going to go ahead and round that up to 27 drops per minute. Number 4, we're going to infuse 1,200 milliliters at a rate of 130 milliliters per hour. So again, the hourly infusion volume is 130 milliliters per hour, and our drop factor is 6. We're going to put that into the calculator. 130 divided by 6, so we get 21.6 repeated forever and ever. But again, we're going to round it to the nearest whole drop because you can't split drops. That's going to give me 22 drops per minute. And one more of this type. The prescription is to infuse 1,000 milliliters, but the rate of infusion is 80 milliliters per hour. And again, always build your units and it helps you find the answer. Divide by our standard drop factor. And this one also is 26.6 repeated. We saw that earlier, didn't we? So we'll round that one to 27 drops per minute. Okay, that is the first type of problem. And then we've got a second one. This one is used to find time. So I'm going to write the formula up at the top for you on the second page. Let me see. I think it's also at the bottom. Hold on. Yes, here it is at the bottom. And that's a lot of words. So I'm going to translate it for you. It is the same thing as saying to find the time in hours, all I have to do is take the milliliters to be infused. Oh, I guess I'm using as many words. The milliliters to be infused over the milliliters per hour. Okay, I didn't make it any shorter, did I? But let's go ahead and plug in. Okay, so for number 1, let me make it a little smaller so I can read the whole thing. It says infuse 800 milliliters of that solution at a rate of 65 milliliters per hour. The infusion was started at 8 o'clock. What time will the nurse expect the infusion to be complete? We're going to start off by finding the time in hours. So for the time, I'm going to take the volume that's going to be infused, that's the 800 milliliters. And I'm going to divide that by the rate, the 65 milliliters per hour. See, what happens is our milliliters cancel so that when you divide, you get 12 let me see here. Put it in your calculator because we're going to have to calculate some minutes. If we take 800 and divide by 65, we're going to get 12.307, blah, blah, blah. Okay, now this is the hours. To calculate the minutes, I'm going to multiply the decimal part by 60. So what I want you to do is grab your calculator. You know how you have the 12.307 whatever in the calculator? Do minus 12 to get rid of the hours. Because right now I know it's 12 hours. And how many minutes? Well, after you subtract the 12, you should still have the 0.30769 whatever in your calculator. Multiply that by 60. I'm going to get 18.46, blah, blah, blah. So it's about 19 minutes. So you multiply the decimal by 60 to get the number of minutes. So now I've got 12 hours, 19 minutes. This thing started at 8 o'clock in the morning. So what time will this infusion be complete? When I add those together, it is 2019, and that's the answer that we're looking for. I think she did on the answer key, she rounded that to 18 minutes. I should have done that. Let me fix it. Okay. Yeah, because minutes are whole minutes. I said that wrong. I apologize. I'll do a better job on this one. We're infusing 1,200 milliliters this time, so let's start by finding the time again. We're going to start with 1,200 milliliters, and it's being infused at 90 milliliters per hour. After doing the division, see 1,200 divided by 90 is 13.333 forever and ever and ever and ever, right? So that's 13 hours. And now I need the minutes. I want you to multiply this by 60. So start with your calculator, subtract out the 13 so that you only have the decimal part in your calculator, 0.33333. Now multiply by 60, and that's 20 minutes. So 1320, and it started at 4 o'clock. So the answer here should be 1720. You know what? My answers are going to be off a little bit because they're very accurate, and I'm not rounding. I think what the whoever built this did is they took only the first decimal, and I don't want to round anything. I want to calculate it with all of it. So we're getting a little bit different answer, and that's okay. That is correct. On number 3, we want to infuse 250 milliliters at a rate of 40 milliliters per hour. If it started at 10, when will it be over? Okay, well, I'm going to start with the 250 milliliters and divide by 40 milliliters. I'm going to put that into the calculator. 250 divided by 40, that's going to give me 6.25. Okay, well, that's 6 hours. Grab your calculator and do minus 6 so that all that's left is the decimal. Multiply that by 60 to get the number of minutes, which should be 15 minutes. So now we've got 0615, 6 hours, 15 minutes. and we're going to add that to 10 o'clock. When will the infusion be over? At 16:15. Two more. We're going to, and again, starting in the same way, we're going to infuse 275 milliliters, and the rate is 35 milliliters per hour. When I put that into the calculator, 275 divided by 35 is going to give me 7.857 blah, blah, blah. The 7 is the number of hours, so 7 hours. I need the minutes, so you're going to multiply this part by 60. Start off, though, by subtracting the 7 so that you only have the decimal part in your calculator. Then multiply by 60. You're going to end up with 51.42 blah, 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 or we're going to call it 51 minutes. I'm going to round it to whole minutes. So 0751 is the length of the infusion. Since it started at 1100, it will end at 1851. If you want to, pause the video and solve number 5 and see if you can get the answer. All right, so you started off by infusing 750 milliliters at a rate of 125 milliliters per hour. After doing the division, 750 divided by 125 is 6. 6 hours. Since it came out a whole number, it's 0600. I'm going to add that to the time it started. That means this infusion will be over at 1500. All right, I'll see you soon.